Welcome to the last video of Section 3, working with TTK-themed widgets. In the previous video, we've learned how to save beat patterns. In this video, we'll learn how to work with TTK-themed widgets. We are almost done programming our drum machine. However, we'd like to end this section by introducing you to the TTK-themed widgets. TK-Enter does not bind to the native platform widgets on many platforms such as Microsoft Windows and X11. The TK Toolkit and TK-Enter originally appeared on X Windows systems, hence it adopted the motif, look, and feel, which was the de facto standard for GUI development on X Windows systems. When TK was ported to other platforms, such as Windows and Mac OS, this motif style started appearing out of place with the look of these platforms. Due to this, some even argue that TK-Enter widgets are rather ugly and do not integrate well with such desktop environments. Another criticism of TK-Enter is based on the fact that TK-Enter mixes logic and styling by allowing both to be changed as widget options. TK-Enter was also criticized for lacking any kind of theming support. Although we saw an example of centralized styling via the option database, the method required styling to be done at the widget level. It does not allow for selective styling of two-button widgets differently as an example. This made it difficult for developers to implement visual consistency for similar groups of widgets while differentiating them from other groups of widgets. As a result of this, many GUI developers moved to TK-Enter alternatives such as WXPython, PySide, and PyQt, and others. With TK-Enter 8.5, the makers of TK-Enter have tried to address all these concerns by introducing the TTK module, which may be considered as an advance to the original TK-Enter module. Let us take a look at some of the features offered by the TTK-themed widgets module. One of the first things that TTK does is that it provides a set of built-in themes that allows TK widgets to look like the native desktop environment in which the application is running. Additionally, it introduces 6 new widgets: Combo Box, Notebook, Progress Bar, Separator, Size Grip, and Tree View to the list of widgets, in addition to supporting 11 core TK-Enter widgets, which are Button, Check Button, Entry, Frame, Label, Label Frame, Menu Button, Paned Window, Radio Button, Scale, and Scroll Bar. To use the TTK module, we first import it into the current namespace. You can display the TTK widgets like this. Code 3.10.py provides a comparison of displays between the normal TK-Enter widgets and the counterpart TTK widgets and produces an output. Notice that the preceding screenshot is taken on a Microsoft Windows platform, as the differences are more marked on systems that do not explicitly use the X Windows system. Notice how TK-Enter widgets on the left look out of place on Microsoft Windows, as compared to TTK widgets on the right, which is the native Microsoft Windows look and feel. Although most of the configuration options for TK-Enter and TTK widgets are common, TTK-themed widgets do not support styling options such as FG, BG, Relief, Border, and others. This is purposely removed from TTK in an attempt to keep logic and styling in different controls. Instead, all styling-related options are handled by the respective style names. In a standard TTK module, each widget has an associated style name. You can retrieve the default style name of a widget using the widget.yinfo_class method. For instance, consider a TTK button. This prints T-button, which is the default style name for TTK.button. For a list of default TTK style names for different widgets, refer to this site. In addition to the default style, you can assign a custom style class to a widget or group of widgets. To set up a new style, To configure the style options for a default style, you use the command. To create a new style from the built-in styles, define a style name of the form newName.oldName. For instance, to create an entry widget to hold a date, you can call it date.tentry. To use the new style on a widget, you use the command. Next, we will discuss TTK theming. Style is used to control the appearance for individual widgets. Themes, on the other hand, control the appearance of the entire GUI. More simply put, a theme is a collection of styles. Grouping styles into themes lets the user switch designs for the entire GUI all at once. Like styles, all themes are uniquely identified by their name. The list of available themes can be obtained by using this command. To obtain the name of the currently active theme, you can change to another theme from the list style.theme_names ; use. To explore various styling and theming related options of TTK, refer to the dummy example. The description of the code is like, the first 3 lines of code import TK-enter and TTK and set up a new root window. The next line, style equals ttk.style, defines a new style. The next line configures a program-wide style configuration using style.configure. The dot character, which is the first argument of configure, means that this style would apply to the top-level window and to all its child elements. This is the reason why all of our widgets get to have a yellow background. The next line creates an extension, danger, to the default style T-button. This is how you create custom styles, which are variations on a base default style. The next line creates a ttk.label widget. Since we have not specified any style for this widget, it inherits the global style specified for the top-level window. The next line creates a ttk.button widget and specifies it to be styled using our custom style definition of danger.tbutton. This is why the foreground color of this button turns red. Notice how it still inherits the background color, yellow, from the global top-level style that we defined earlier. The next 2 lines of code demonstrate how TTK allows for styling different widget states. In this example, we styled different states for a ttk.button widget to display in different colors. Go ahead and click on the second button to see how different styles apply to different states of a button. Here, we use map to specify dynamic values of style for changes in state of the widget. The next line fetches the current applicable theme. It then overrides some of the options for the theme's entry widget using. The next line defines an entry widget but does not specify any style to it. It therefore inherits its properties from the theme we configured earlier. If you now type anything in this entry widget, you will notice that it gets a padding of 10px and the foreground text color is red inside the entry widget. Now that we know how to make our widgets look more like native platform widgets, let us change the play and stop buttons for our drum machine to ttk.button. Let us also change the loop check button from tk-enter check button to ttk check button and add a few separators in the play bar section. The play bar before and after making the changes. We first import TTK into our namespace and append TTK to the play and stop buttons. We then simply modify the buttons and check button in the create_play_bar, replacing button with ttk.button and loop button with ttk.checkButton. Note that these changes make button and check button look closer to the native widgets of your working platform. Finally, let's add TTK separators to our play bar. The format for adding separators is. Note that we cannot change the buttons in the right button matrix from button to TTK button. This is because TTK buttons do not support specifying options like background color. This concludes the last iteration of this project. In this iteration, we first saw how and why to use TTK-themed widgets to improve the look and feel of our programs. We then used TTK buttons and TTK check buttons in our drum program to improve its look. We also saw the reasons why certain TK-enter buttons in our program could not be replaced by TTK buttons. Awesome! We have successfully learned how to work with the TTK-themed widgets. This video concludes the third section of this course. To summarize, we started by learning how to structure the TK-enter program as classes and objects. We then decided the data structure for our program. This enabled us to set the ground for writing the rest of the program logic, maintaining a clean separation between data, logic, and its visual representation. We saw the vital benefits of deciding the data structure in advance. We also worked with more TK-enter widgets such as Spinbox, Button, Entry, and Check Button. We also saw the Grid Geometry Manager in action in the section. We then saw how to bind widgets to higher-order functions using command callbacks. This is a very common technique used in GUI programming. We then understood multi-threaded programming in the context of TK-enter. We moved the audio playback onto a separate thread. This enabled us to keep the audio playing without hampering TK-enter's main loop in any way. We then understood how to persist an object's state with the pickle module, and then how to unpickle it later to retrieve the state of the object. Finally, we saw how to use TTK-themed widgets to ensure that our GUI feels native on the platform where it is run. Congratulations! You have now completed coding your drum machine. In the next section, we will build a game of chess in TK-enter.